Okay, so we did Jack and Jill went up the hill the other day, and coefficients. Coefficients are the numbers that are sitting in front of the variable, and constants are the numbers that stand alone. So if I'm talking about number 1 and I'm talking about coefficients, I'm going to say 64. If I'm talking about constant, I'm going to say 24. Okay? So number 2, I'm just going to abbreviate. If we're talking about the coefficient there, it's -8. If I'm talking about the constant there, I'm talking about 30. Oops, that was weird. 36. On number 3, I'm talking about the coefficient. I'm talking about -3 and 18. And there's no constant. There's no number that stands alone. Number 4, my coefficient, 42 and 27. My constant, the number that stands alone, is going to be -1. Okay, next page. Then it says, right here we have some triangles. And it says for each triangle, write the ratio of the relationship between the height and the base. So that means that I want the height over the base. And as I'm looking at each one of these, height, that's how tall these are. Okay? So those are going to be my heights, and then I'm going to change colors, and my base are the numbers down here at the bottom. So if I'm looking at each one of these, okay, come on, there we go. So the first one, I'm going to have 10 over 10. The second one, I would have 15 over 4. The third one, 15 over 15. And last but certainly not least, 12 over 3. Because all it did was say the ratio. We didn't have to find the rate of change. But the next one says to find the unit rate. So that means I'm going to simplify it, because remember that unit rate means that it's something per one item. Okay? So that means when you have a ratio, there's going to be a 1 on the denominator. So if I look at the first one, I'm actually going to change colors real quick. So 10 over 10 would become 1. 1 over 1. 15 over 4 would be 3.75. Now, that can be written over 1. 1, and last but not least is 4. So the next one says, how can these ratios compare to the steepness of the triangle? So if I look at how steep they are, the first one and the third one, they have the same steepness because they have the same unit rate. Now, this one has a unit rate of 3.75. This has a unit rate of 4. They're both steeper than the other two, but if we look closely, the fourth one, this one right here, is actually the steepest one. So how can you use these rates to compare the steepness? The higher or bigger the ratio, the steeper the line. And then there we go. So over here we have Jack and Jill. On Monday, they walked from their home up the hill to get to the bus stop. They walked 4 yards every 3 seconds. Now, thinking about unit rate, there are 2 things that I need to talk about. Number 1 is anytime you have money, it's going to be money over some item. So money per something. The other thing is you're going to have distance over time. It's always distance over time. So when I'm looking at this, this says 4 yards every 3 seconds. So we're going to be using that in just a seconds. Okay. Write an equation to express the distance over the time. So we have distance over time. So our distance that we just talked about is 4. Our time we just talked about is 3. Now, we actually want the d to be all by itself. We want it to say d equals. So if we do that, we can multiply both sides by t. When we do that, these cancel, and you get 4/3 t. Does this represent a proportional relationship? Does this have a proportional relationship? Well, number one thing, does it go through 0, 0? Yes, it does. Because if there's 0 time, you've gone 0 amount. Is it in the form y equals kx? There's nothing added or subtracted. It sure is, and the constant of proportionality is the number or the coefficient of x. So the k value is equal to 4/3. Now here, we just said it goes through 0, 0. So now we're going to take the equation we came up with, and we're going to plug in our t values. So if I was to replace t with 1, I would get 4/3. Now, you can write it as 1 1/3, but it's a repeating decimal, so you're not going to write 0.3 because that does not actually mean the same thing. So then I'm going to come here and I'm going to do 4/3 and I'm going to plug in 3. That's the same thing as saying 3/1. Now, the 3's canceled, but I will actually multiply it out so you can see it. 12 divided by 3 gets you 4. I'm just changing color so you can see. I'm going to skip this one for just a second, and I'm going to come down to this one. And we're going to multiply that by 7.5. And when you do that, hold on just a second, I'm actually going to turn it off Wi-Fi for a moment. So if you multiply these together, remember that 7.5 is actually over 1. So this would get me, I'm going to write it down here, this would get me 30 over 3, which would get me 10. And last but certainly not least would be, oh, it's not really the last one, 9, which is the same thing as 9 over 1, 36 over 3, which would be 12. Now I'm actually going to do this one right here, but I'm going to come down here and do it. This time it's saying my D value is 8. Okay? Now, hopefully remember that you multiply by the reciprocal to get rid of. So this is over 1, so that would get me 24 over 4 is equal to, this 4 cancels, this 3 cancels, we're just left with t, so that would be 6. So 6 would go here. Now, I'm going to try really hard to plot these points. So 0, 0 is pretty simple, Simon. 1 1/3, so 1 and itty bit more. And then 3, 4. 3 and 4. And 6 and, 8. And 7.5 and 10 and 9, is that right? 7.5 and 10, and then 9 and 12. Now, normally I would have a straight edge to be able to do this. That was horrible. But there you go. Now, what is the unit rate? What does it go up by every time? Now, every single time we multiplied by 4/3. So that is our unit rate. What does that mean? It means for every 4 yards, it took 3 seconds. Skipping that one, we're going to come to here. Rate of change. So we're talking about the rate of change. Describes the amount, the dependent variable. So dependent variable is your y. And in this instance, our y was distance. Changing compared with the amount of the independent variable, and that's your x, and this time around we're talking about time. Identify the rate of change. Again, what did it go up by? It went up by 4/3. I'm going to give you a second to think about this one. Consider the rate of change, the constant of proportionality, the unit rate. So 2, 4, and 6. Look back at those questions. What do you notice about all 3 of them? They are all the same. Okay, we're going to come here. Slope of the line. Okay? So, we can't really do this whole thing like we like to do when we're in class because we don't have patty paper and all of that. So, we're going to do it just a tad bit differently. And what I want to do is it gives you 3 points that are on the line. And we're going to look at this first one. Now, we talked about rate of change earlier, and it's the height over the base. So I need to see how high this is. So if you look, these are in thirds. So this is 2/3, this is, 1/3, 2/3, 3/3, and this is 4/3. Oops, I did not mean to put 3. There we go. So how tall is this? This is 4/3 tall. How far across is it? It is 1. So if I'm talking about that first triangle, it's 4/3 over 1, which is 4/3. If I'm talking about the next triangle, and I used a different color. Oh, you know what? We're going to write the little 1 in there, change it back, and erase this. There we go. So, how tall is that? Well, it goes from here all the way up here. See, it's across from 4. So that's 4 tall, and down on the bottom, it goes over to 3. So the second triangle is 4/3. So as you see, we're consistent on what we're doing. The rate of change is constant. It does not change. Now we're going to do, we'll do green. We're going to do that with this one. And hopefully, there we go, that wasn't too bad. Okay, so the green triangle, how tall is it? That's 8. How far across is it? It's 6. So I have 8 over 6. When simplified, it still is 4/3. So if you notice on this, the rate of change or the steepness of this did not change at all. The steepness stayed the same. This has a constant rate of change. Okay? Similar triangles. Similar triangles have proportional sides. If you notice, all three of these, we set them up in ratios. They are all equal to each other. Okay, we're going to skip this page because I already did it. And this is the highlighting page. We have a lot of highlighting. I don't want that color. I'm going to just go with yellow for this. Slope. This is an important word. Super important. This deals with direction and steepness of a line. And it's usually represented by the letter M. Another name for this is rate of change, just like we've been doing. It is the vertical distance, which means the height. And that is, to the, I need to erase. There we go. It is a ratio between the vertical distance and the horizontal distance, the change in those. So this is our base. So it's the vertical distance, the change in the vertical distance, and the change over the change in the horizontal. So again, it's just height over base. Okay, so we have height over base, or the change in y over the change in x. The other thing that we have to highlight is actually over here. The sign. When it's talking about the sign, it's talking about whether it's positive or negative. Of slope indicates the direction of the line. If it is positive, then it will increase from left to right. So if it's increasing, it goes up. If it is negative, it will decrease from left to right. Another way to say that is it would be positive if as the x's are getting bigger, the y's are getting bigger. If it's negative, as the x's get bigger, the y's actually get smaller. Okay, so let's come down here. Okay, the general equation of a line that is proportional looks like this, where this right here means slope. So instead of being kx, it is now going to be mx. The constant of proportionality in this case is the m value. Okay, so let's come here. Going through the origin, equation of the line not through the origin. So on this right here, we have to read what it says. It says Jack and Jill's Aunt Mary lives 10 yards closer to the bus stop. After spending Monday night at Aunt Mary's house, they leave for the bus stop from there on Tuesday morning. They walk the same rate. Ooh, I like how it says that. They walk the same rate from either house. The other part that was important is she lives 4 yards from their home. So that's important information. So if I look over here at this graph, number one thing you have to understand is this is home. If you read right here, it says distance from Jack and Jill's home. So it says that Aunt Mary, lives 10 yards from their home. So this right here would represent 10 yards away. So this is Aunt Mary's house. Okay, that's Aunt Mary's house. The other thing says that the slope of the line, or the rate of change, is going to be, actually I'm going to keep that. I'm going to actually highlight. I'm going to pick a different color to highlight with. Okay, it says that it's 4/3. So if I'm talking 4/3, that means that, I'm going to use a pencil real quick. If it's talking 4/3, that means when I draw this, that this is 4 high, this is 3 across. And the other thing you have to notice is this is not going by ones, it's actually going by halves. So be careful when you do the 3 on the bottom. So I need to go over to 3, which 3 is right here. I actually want to make this smaller. There we go. So I need to go over to 3, and that's 3 long right now. That's 3 long, and I need to go up to 4. So that gave me 4. So now I'm going to draw a point right there. Then I'm going to do, I'm going to do it again. I'm going to go to the right 3. So if I go to the right 3, and I'm going to go up 4. Oops, that was horrible. And hopefully, it's an okay line. It's not great, but it's not bad. So that's the new line that we would come up with, okay? Their rate of change, how do the slopes compare? They're exactly the same. They're both 4/3. But the starting point, if you look at it, the starting point for the second line is actually 10 units above. So it's 10 units or yards above the origin. Now the question down here is this new line proportional or not proportional? Well, proportional means it goes through the origin. So this is not a proportional line because it does not go through, it does not go through the origin. Now, it is a constant rate of change, that's good, but it does not go through the origin. So let's come over here. Now, I'm actually going to highlight this right here. That's the first line. That's this line right here. Okay? Why? You know what? I'm going to erase that and I'm going to use a different color. Okay, this was Y1. This right here is Y2. So those are the points for the line Y1. Okay, it says it right there. But I want the points that go here. I want the Y values that go here. So that's what we're going to do now. We're going to find those points. So it did not, we're going to, you know what I'm going to do? Don't do this on your paper. Do not do this on your paper. Okay, I'm going to do this for a minute. And then I'm going to erase it, okay? Don't do it on yours. We're going to look at this being the X value right here, this being the Y value up on this graph. So if I look at this right here, that's the first value. So it's 0, 10, because it's 10 away from where we started, or from their house. If I look at 3, that's the other dot that we plotted right here. That's at 314. And then at 6, this point right here, it's at 618. Okay, now I'm going to erase these numbers right here. And I want you to compare these. This was 0. This was 0, that's 10. 4, 14, 8, 18. What happened? Hopefully you noticed that all they did was add 10. So this is the same thing as 1 1/3, so I'm going to add 10. I'm going to add 10. So the only difference between this column right, oopsie daisy, this column right here and this column right here is they added 10. Okay? The rate of change never changed. Never, it was consistent. It is still 4/3. Now, the original line is this right here. It's in the form of this. But we just said a moment ago that we had to add 10 to everything. So we're going to take the original equation, this one right here, and we're going to add 10 to it. And this equation will get you not only the graph, but it'll get you the table. Okay, so if we look at this right here is slope. M stands for slope. But this says it's going to vertically translate B units. B is going to be the distance from 0, 0. So we're starting off with this equation right here, but we're adding on the distance it goes from 0, 0. Okay, this next one. Now, the highlighted part for this one says that they're walking back home from the bus stop, which is 30 yards from the house. Right here, it's 30 yards from the house. Down here is the house. Up here is where the bus stop is. Now, the other part is that they're still going 4 yards every 3 seconds. Okay? So we have to look at those things. I actually want you to write down this because this is important to know. The very first thing that we have to do every single time is decide, is this proportional or is it non-proportional? Okay? If it's proportional, it's going to be y equals mx. If it's non-proportional, it's going to be y equals mx plus b. Oops. We'll do this. So, second thing, you need to find slope. So, is it positive or is it negative? That was weird. Then you have to remember that in order to find slope, it is the height of the triangle over the base of the triangle. So that means it's the change in y over the change in x. Then last but certainly not least, you need to find b. So if I'm looking over here, is this proportional or not proportional? Well, as I look at that line, does it go through 0, 0? No, it does not go through 0, 0. Does not, I should say it, does not go through the origin, which is the point 0, 0. Now the next thing says, is it positive or negative? So up here a minute ago, we said this is a positive slope, this is a negative slope. So let's look up here. That looks like it's going in the negative direction. So I'm going to say it's negative because as the x values get bigger, the y values get smaller. And then we're going to do number 3, but I'm just going to use the graph to do number 3. So, first things first. Whoopsie daisy. Is it proportional or not? It's not proportional, so that means we're using this form. Then it said to find the slope. Okay, well, didn't it tell us that the slope was exactly the same right up here? So that means the slope is still the same. Okay, slope is this. But we just said that it's a negative slope, so it needs to be negative 4/3. Then our b value. That means how far away is it? How far away is it from home? From 0, 0. It's 30 away. So the equation of this line is y equals negative 4/3 x plus 30. Okay, then we're going to go to this. So, first things first, A, B, and C. Are they proportional or not proportional? This would be non-proportional, and it's going to be y equals mx plus b. This one's going to be proportional. So this is y equals mx. This one down there is going to be non-proportional because it doesn't go through 0, 0. So it's going to be this. Okay, so we did that first part. The next part says to find the slope. So we're going to come right here, change it back to the blue, and we're going to draw our triangle. How high is it? Well, it started here at 20, went up to 28, so that's 8 tall. Came from 0, came all the way over to 60. So that means our slope is going to be 8 over 60, but that's not in simplified form. We need it in simplified form. 4 goes into both of those numbers, so oopsie daisy, I didn't mean to write 4. You'd get 2 over 15. Now the b value, how far away is this from the 0, 0? It's 20 away. So that means my equation is going to be y equals 2/15 x plus 20. Next, this goes through 0, 0. So that means that we just have to find the slope. So if we're going to find the slope on this one, we have to find where it goes through the lattice points. The first time it does that is at this point right here. And as I'm looking at this, it goes up to 160 and it goes over 2.5. Now you may be telling yourself, oh, I don't like those points. That's fine. You could have used this one right here, which would have been perfectly fine. I'm just going to do an upside down triangle. It doesn't matter. And this height is 320. And this across is 5. So you can either find the slope by saying 320 over 5, or you can do it as 160 over 2.5. And when you simplify both of those fractions, hopefully you get 64 miles per hour. So the equation is going to be y equals 64x. Okay, last one on these graphs. Okay, so slope. Now, I'm going to tell you right now that these aren't obvious ones. And so what I'm going to do is actually I'm going to just pick a point where it might go through. Okay, so it might go through right here. We have no idea. This is not a very pretty graph, but I'm just going to tell you we're going to pick that number. So from 30 to 45 is 15 tall. From 0 over to 12 is 12 across. So my slope is going to be 15 over 12. Simplified would be 5. Is that right? 15 over 12, yes. And 5 over 4. Now B value would be over here. How far away from 0, 0? It is 30 away. Guys, another name for this is y-intercept. So I make my equation. Y equals, my slope was 5/4. 5/4 x plus my b value of 30. This one, we need to find the slope of the line. So while finding the slope of the line, we're supposed to figure out how high up I go before I get to that point. Well, if you notice, I didn't actually go up to get over there. So that means it's 0 over 1. Anything 0 over a number is 0. All horizontal lines have a slope of 0. All horizontal lines have a slope of 0. Now down here, we need to fill in this box. It tells us it's proportional. So proportional means that it has to go through 0, 0, and y over x has to be the same every single time. So if I do this, that means 0, 0. Well, I should say y over x except for the 0 over 0. That'll never work. So 12 over 2 will get me 6. So what over 1 is going to give me 6? 6 is. So aren't I just taking this number and multiplying it by 6? This and multiplying by 6? This would be 18, 24. Look at it. 6 over 1, we get 6. 18 over 3, we get 6. 24 over 4, we get 6. That is a proportional relationship. That will work every time. Down here it says a non-proportional. That means it can't be 6, because that would have gotten us 0, 0. It has to be another number. So I'm just going to pick a random number, and we're going to say the slope is 3. That means it goes up by 3. So 15 plus, or 12 plus 3, 15 plus 3. Now, if I go backwards, I actually have to subtract it. So that would get me 9. That would get me 6. Is that right? Yes. So you could have picked anything for your slope. You could have picked negative numbers if you wanted. Now these two things, they want you to draw lines that are non-proportional and proportional. So this first one, if it's proportional, it automatically has to go through 0, 0. Voila. This one, non-proportional, that just means that it can, oh, I don't know where the dot went. I think it's right here. I'm going to make it bigger. It could be any one of these lines. It could be any one of these lines. And I know those aren't straight, but you know what? Could be anything except for through 0, 0. I hope